Hey everybody, today we are going to continue our chapter on transformations with section 9.2, which is going to be translations. Yesterday we did reflections, which was a rigid motion, and translations are also considered rigid motions or isometries. Remember that an isometry or a rigid motion is any transformation that maintains the size and the shape of your preimage as it transforms onto the image. So when we look here, we have a translation. A translation is when all of the points in a figure are slid the same distance and the same direction. So when we look here at triangle ABC, each point in this triangle is slid the same distance and direction to form triangle A prime, B prime, C prime. And as you can see, the two triangles are the same size and the same shape. The way that we describe how much we move a translation is by using what's called vectors. A vector is a quantity that shows both direction and magnitude, which can also be considered length or speed. So when we look at the pieces and parts of a vector, okay, a vector has an initial point and it has a terminal point. So what happens here is you'll notice that this has an arrow. Okay, your arrow is going to point to your terminal point. So it starts in this case at E and will end at F. Now, it does look similar to a ray, but please know that it is going to be different, and notice that we are doing this from point to point. All right. So the way that we name our vector is very similar to a ray. Remember that when we named a ray, we had to start with the initial point, and then we picked any point that was on the side of the arrow. All right, but that initial point always came first. All right, that is going to be the exact same thing that happens here with a vector. Okay, our initial point in this case is E. It will come first, and then my terminal point is F. It will always be second. So no matter what direction your vector is going, your initial point will come first in the name, your terminal point will come second. Now, where it differs slightly from naming a ray is you'll notice this symbol at the top. The ray had the full arrow at the top of the two letters. A vector only has half of the arrow. All right, so that is how we notate the symbol for a vector. Also notice that we do have a naming letter here. So I can also call this vector V. So when we're naming these, we have two different types of ways that we can name them, with the two letters, naming your initial and your terminal point, or just that single naming letter if one is given to you. All right, if you have any questions about that, please make sure that you write that down under your vocabulary questions. All right, we're going to do a little more with the vocab here, starting at the top, looking at component form. Now, one of the things that I want you guys to do real quick is in your notes over there in that left-hand column, please highlight where it says component form and this AB right there. So highlight that so you can make note of that in your it stands out in your notes, because I want you to make sure you know the difference between component form, which we're doing now, and coordinate notation, which we'll do in a little bit. All right, so the first thing that we're looking at for component form is we are looking at, one, these are angle brackets, not parentheses, okay? So this is not an ordered pair. It looks similar to an ordered pair, but we're using angle brackets, which notates that we're actually talking about a vector. All right, so when we're looking here is A comma B. A is our horizontal change and B is our vertical change. So if we look at vector PQ, notice that it goes over 1, 2, 3, 4, 5. I have a change of 5 over to the right. All right, with Q, I have a vertical change. I go up 3 to get to Q. So my component form for vector PQ is 5, 3. Again, making sure you're using those angle brackets. It is very important when you are writing your vectors in component form to make sure that you are clearly using angle brackets and not parentheses, okay? If you're using parentheses, it is wrong because you are writing a point rather than a vector, all right? Also, make sure you're not kind of doing little half-hearted lazy ones that could kind of look like they could go either way, all right? Because if I can't tell the difference between whether it's a parenthesis or an angle bracket, then I will mark it wrong. So please, please, please make sure you are being very clear with your angle brackets. All right, so we are going to go ahead and move on to example 1. And we want to start by naming the vector, all right? And we're going to start by looking at that as, okay, what's our initial point? What's our terminal point? So when I look here, the arrow is pointing to point N. So that means that N is my terminal point. Okay, the other side of that is M, so that is where it starts. The vector starts at M and ends at N. So then when I name my vector, I put them in that order, M first, then N, with the symbol with the half arrow on top of it. All right. Now, I want to write this vector in component form. So I start with figuring out what my horizontal change is. So I'm going to go 1, 2, 3, 4. All right. I am moving to the right 4 units, okay, in a positive 4 direction. Now, notice here, my vertical distance is down 2. So it's a negative direction. All right, so just like here, we're going to keep on, keep our sign with the distance change. If it's a positive direction, make your point positive. If it's a negative direction, make that point negative. All right, so we are using, again, those angle brackets to show that it is not a coordinate. My vertical or my horizontal change is a positive 4. My vertical change is a negative 2. Okay, one of the things that I want you guys to notice is that it does not matter where I have, sorry, stuff jumped kind of everywhere, that I don't know what the coordinates are for M or N. All right, this can be placed anywhere it wants on the coordinate plane. I could put it here, all right, and have it go this way, but it doesn't matter. It will still have the same horizontal and vertical change no matter where I put this vector on the coordinate plane. All right, so your component form never changes for your vector just because it moves on the plane. All right, it doesn't matter that we don't know those coordinates. It's all about the horizontal change and the vertical change. All right, so if you have questions on that, please go ahead and write it on your papers now. Whoop, too far. Okay, example 2. We are going to look and determine whether or not each transformation appears to be a translation or not. So when we're looking at this, and I look to see from the blue to the red, did this just slide over? And hopefully you can see pretty clearly that no. Oh, that's not a very straight line. If I were to draw the line down the middle, this is actually a reflection, okay, which is what we talked about yesterday. So no, this is a reflection. All right, so let's take a look at B. If we go from either red to blue or blue to red, this just slid over, all right, which is what our translations are. So yes, it is a slide. And remember that we're only going to use the slide terminology when we are doing questions like this. All right, every point has slid over the exact same amount. All right, but beyond questions like this, please make sure you do not use the word slide, you use the word translation. Again, any questions, go ahead and write those down now. Okay, so the formal definition of a translation actually uses vectors, all right? So it's moving along the exact same amount as each vector. So if I were to translate P onto P prime, we can look at this and see if I were to copy this vector, all right, and I take this and I just drag it up, you can see that I moved P to P prime along that vector. I was a little off when I drew it. Oh, look, I already had it. So that one. All right. So we want to do the same thing over here with this one. I want to translate this triangle along this vector. So one of the things that you guys can do if you want to be more accurate is you can sketch this on a piece of paper, and just like a scratch piece of paper that's on that you have at home, and you can kind of follow along with me and go a little closer. But what we're going to do here is something that you will not be able to be as accurate as I am able to be, because you are going, you're on your own paper. You don't have the ability to do the tools that I do. But what we're going to look at is, okay, we copied this vector right here, and I'm going to put it at the bottom of my triangle point. And right here, I'm going to draw a point for where the vector is going to move that to. All right. Now, I have the ability, which again, I understand that you do not have at home, so yours will not be as perfect, is I'm just going to slide that vector to the next point in the triangle. And again, if you're using a piece of paper at home, you can kind of like do a little bit better of a guess of where it goes. So you can kind of just tear it so that it's the same length as the vector, and then you can kind of just watch your angles and guess your angles as best you can. But again, don't stress if yours isn't going to be as pretty. I'm not worried about that. Right now, you are just sketching. All right, so there's my second one. And then we're going to move the vector to the third point. We're going to draw this dot right here. And then we are going to connect our points for our image of our triangle. All right, so that is our triangle as it has been moved along the vector V. All right? Again, you are just doing the best that you can. We will actually in class go through a way to do these a little more accurately on your own papers. All right? If you have any questions, go ahead and write them down now. And let's take a look at our next example. So what we want to do is we want to draw the image of the triangle here after we've translated it along the vector -3, 2. So one of the things that I want you to notice over in your left-hand column of your notes, it says, your general translation along your vector AB, which is, your title here. And you have that this is coordinate notation. So right here, this is one way to write a vector or to write a translation in coordinate. I can't spell coordinate. Coordinate. Yeah. Sorry. Okay, so this is our coordinate notation of what a vector looks like. So from any point x, y, we're going to add the horizontal change to the x, add the vertical change to the y. So when we have our vector -3, 2, okay, in coordinate notation, come on, erase. It becomes this, x -3, because our vector change was or horizontal change was a -3, and y +2, because our vertical change was a +2. So that means that every x coordinate is going to have 3 subtracted from it. Every y coordinate is going to add 2. All right, so if I take my 0 coordinate here and I subtract 3, I'm going to get -3. My y coordinate, I'm going to add 2, so this is going to go to 5. Now, these are parentheses because these are ordered pairs. These are coordinates, so make sure angle brackets are vectors and parentheses are points. All right, so looking at the next one, we have 1. We're going to do 1 - 3 is a -2. -1 + 2 is a 1. And -1 - 3 is a -4. And again, -1 + 2 is a +1. So then we're going to go ahead and graph these points. All right, we're going to get -3, 5, which is going to be right here. Then we're going to have -2 up 1 and -4, 1. And then from here, we are going to connect our points together. So now we have successfully graphed the translation of our triangle. All right. And if you look at the vector going from here to here, it is moving to the left 3 and a +2. So this is the vector that each point was moved along. And I can move it over here and see that this is the same. And I can move it to the top and see that that is the same. So each and every point, I can drag it the whole way down the triangle, down across the bottom and up across the other side, and it stays each point the same distance away from the pre-image. All right, so that is translations. If you have any questions, be sure that you ask them in class tomorrow. Have a wonderful day, and I will see you guys later.